Hi guys. Today we're going to continue simplifying a radical, but we're going to throw in some variables because this is an algebra class. So of course we have to deal with variables. I'm going to have one example and then I'm going to ask you to try a couple on your own to make sure that you fully understand the concept. Just like yesterday, we will be taking this and we will be expanding it out to what's called the prime factorization. We'll practice that a little bit more too during our live sessions. To do the prime factorization, we'll start by doing a factor tree on the number 72. Remember, you're going to keep splitting it until you can't split it anymore. Now, we are looking for pairs of numbers because it's a square root, so we want two of a kind. So if you are able to get a pair of numbers and you don't want to split them anymore, that's okay too. Now, if you wanted to, you could keep splitting this and make it 2, 3, and 2, 3, and that would also work. But if you're able to get a pair of numbers that is not prime numbers, go for it. For our variables, we are also going to be looking for pairs. So there's a couple different ways that you can do that. I'm going to show you first the long way to do it, and then I'll show you a shortcut after we've seen the long way. For the long way, what we're going to do is we're going to take the exponent and we're going to write each variable that many times. Remember that x to the third really means that we are multiplying three x's together. So let's write that out. X times x times x. Y to the fourth really means we're multiplying four letter y's together. So let's write that out. And z to the fifth means five letter z's. So here I have my prime factorization. Now I'm going to look for pairs, two of a kind. Remember, we stopped at 6 times 6 because that was already a pair. So we can go ahead and circle our sixes. From each pair, one will go out of the radical and the other one will poof, disappear. So make sure that one gets out and that the other one goes away. Now we can also look for pairs in our variables. So if you're a visual learner, writing out all the variables is going to be really helpful because you can visually see, okay, I have two letter x's, one gets out and one goes away. And then notice that my third letter x, it didn't make it in the circle, and that's okay. For my y's, I have two letter y's, one gets out, one goes away, and then I do have another pair of y's over here. One gets out, one goes away. So a total of two y's are going to get out of that radical. The same thing will happen with the z's. I have a pair and I have a second pair. So what we're going to do now is we're going to look at everything that got circled and we're going to write it on the outside and it all gets multiplied together. So I have a 6, an x, a y, a second y, a z, and a second z. So 6x, y, z, z on the outside. And then anything that did not get circled will stay underneath the radical. So I have this 2, I have this x, and I have this z. For a final answer, everything should be multiplied back together. So I am going to put some exponents on my variables that got out of the radical. And then we talked about this yesterday. If you have multiple numbers that are getting out or you have multiple numbers that are left on the inside, you should also multiply those together. At most, you should have one number on the inside and one number on the outside. This is my final answer. Now, if you're a visual learner, again, writing everything out can be really, really helpful because you can see and circle those pairs of numbers. But there is a smaller way to get your variables to get out of that radical. Remember that we're looking for pairs of numbers, which is two of a kind. So a shorter way to get your variables out is to divide the exponent by 2. When you divide by 2, you're finding how many pairs you can create. And so that will tell you how many letters can get out. When we're doing our dividing this time, we're going to divide with a remainder, which we haven't done in a long time. Normally we divide with the decimal, but we need a remainder this time so we can see if any variables remain inside the radical. So let's try it with this one. So x to the third, I'm going to do 3 divided by 2. So 2 goes into 3 once evenly with 1 remainder. The one time that it divides evenly is the 1x that gets out. And the 1 remainder is the 1x that remains inside. So 1x out, 1x in. Let's try the letter y. So it was y to the fourth, so I'm going to do 4 divided by 2. 4 divided by 2 is 2 with no remainder. That means I get 2 y's that can go out and no y's remain inside. Think about, we have 4, we can make 2 pairs of 2. And that's the 2 y's that got out. All right, z to the fifth. So 5 divided by 2 is 2 with a remainder of 1. Anytime you have an odd exponent, you're always going to have a remainder of 1. It's the odd man out. He doesn't get to go in that pair with everybody else. So 2 z's escape and 1 remains inside. So this is an alternate way to deal with your variables, or doesn't hurt to write them all out. All right, let's see how you do with these 2 trying your own. So go ahead and pause the video, try these 2, and then when you're ready, restart. All right, for number 1, I got 8 c to the third on the outside, and then the square root of 2. 8 c to the third on the outside, and then the square root of 2. Look, 6 divided by 2 is 3. Let's look at the second one. A to the third. 3 is an odd number. I'm going to have a variable left inside the radical. So on the second one, I got 10a, and then the square root of 3a. 10a, and then the square root of 3a. All right, guys, that's it for today.